The National Electrical Code, or NEC, addresses the requirements for service entrance conductors. Service entrance conductors are the wires that bring electricity from the utility company's service point to the building's service equipment, typically the main circuit breaker panel. According to the NEC, service entrance conductors generally cannot be run above the roof level of a building or structure. There are, however, exceptions to this rule. The first exception states that service entrance conductors may be run above the roof level of a building or structure if they are terminating at service equipment located on the exterior of the building or structure, and this service equipment is mast-mounted. This situation often occurs when the utility companies drop the wires coming from the pole are higher than the building's service equipment location. The second exception is that overhead service entrance conductors may be run above the roof level of a building or structure to terminate at a service head, but only if the conductors meet the requirements outlined in Article 230.7 of the NEC for overhead spans. In other words, the installation must adhere to specific rules related to clearance from the ground, buildings, and other structures. Regarding the length of overhead spans, the NEC stipulates that overhead service entrance conductors, other than spans described in Section 230.24 a, must not exceed 10 feet in length from the last point of support to the point where they attach to the building or structure. This 10-foot limit is designed to minimize the risk of mechanical damage or stress on the conductors, as well as potential safety hazards. The NEC specifies requirements for the type of service drop conductors permitted, typically insulated conductors suitable for outdoor use and exposure to weather. It also defines the necessary clearances from ground level, building structures, and other objects to ensure safety. The NEC addresses the proper methods for attaching the service entrance conductors to the building or structure, including the use of appropriate hardware, such as insulators and clamps, designed to withstand the weight and tension of the conductors. The code also mandates the use of a drip loop, which is a bend in the service entrance conductors that allows water to drip off before it reaches the service head or other connection points, thereby preventing water from entering the electrical system. Proper grounding and bonding of the service entrance conductors and associated equipment is critical for safety. The NEC outlines requirements for grounding electrodes, grounding conductors, and bonding connections to ensure a low impedance path for fault current to return to the source, which helps to trip over current protection devices, such as circuit breakers, quickly in the event of a fault. The NEC requires that service entrance conductors be protected from physical damage. This protection can be achieved through various means, such as installing the conductors in rigid metal conduit, intermediate metal conduit, or rigid non-metallic conduit. The type of protection required will depend on the specific location and the potential for damage. The NEC emphasizes the importance of proper workmanship in the installation of service entrance conductors. This includes ensuring that all connections are tight and secure, that conductors are properly supported, and that the installation is neat and professional. The NEC requires that service entrance equipment, including the service disconnect and overcurrent protection devices, be readily accessible. This accessibility allows for easy maintenance, inspection, and operation of the equipment. The NEC specifies the minimum size of service entrance conductors based on the calculated load of the building or structure. The load calculation must take into account all of the electrical equipment that will be connected to the system, including lighting, appliances, and heating and cooling equipment. The NEC also addresses the allowable voltage drop in service entrance conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The code provides guidelines for minimizing voltage drop by selecting conductors of appropriate size and length. The NEC requires that service entrance conductors be clearly identified. This identification can be achieved by using color-coded conductors or by labeling the conductors with their voltage and amperage ratings. The NEC requires that all electrical work be performed by qualified individuals who are knowledgeable about the code and have the necessary skills and experience. In many jurisdictions, electrical work must be inspected by a qualified electrical inspector to ensure that it complies with the NEC and local codes. The NEC is constantly updated to reflect changes in technology and best practices. It is important to stay current with the latest edition of the code to ensure that electrical installations are safe and compliant. Many local jurisdictions have their own electrical codes that are based on the NEC but may also include additional requirements. It is important to check with the local authorities to determine the specific codes that apply in a given area. In addition to the NEC, other standards and regulations may apply to service entrance conductors, such as those issued by Underwriters Laboratories, or ALL, and the National Electrical Manufacturers Association, or NEMA. These standards provide guidance on the design, construction, and testing of electrical equipment. When selecting service entrance conductors, it is important to consider the ambient temperature in which the conductors will be installed. High ambient temperatures can reduce the ampacity of conductors, so it may be necessary to use larger conductors or direct the ampacity of the existing conductors. The NEC provides tables and guidelines for adjusting conductor ampacity based on ambient temperature. When installing service entrance conductors in conduit, it is important to consider the fill rate of the conduit. The NEC limits the number of conductors that can be installed in a given size of conduit to prevent overheating and damage to the conductors. The NEC provides tables and guidelines for calculating conduit fill. When splicing service entrance conductors, it is important to use connectors that are listed and labeled for the specific type of conductor being spliced. The connectors must also be properly installed according to the manufacturer's instructions. The NEC provides guidelines for the proper methods of splicing conductors. When terminating service entrance conductors at equipment terminals, it is important to use terminals that are listed and labeled for the specific type of conductor being terminated. The terminals must also be properly tightened to the manufacturer's specified torque. The NEC provides guidelines for the proper methods of terminating conductors. The service entrance conductors must be installed in a neat and workmanlike manner. This includes ensuring that the conductors are properly supported, that they are not exposed to physical damage, and that they are properly identified. The NEC provides guidelines for the proper methods of installing conductors. The service entrance conductors must be inspected by a qualified electrical inspector before the electrical system is energized. The inspector will verify that the installation complies with the NEC and local codes. The NEC is a complex and comprehensive document. It is important to consult with a qualified electrical contractor or engineer to ensure that electrical installations are safe and compliant. The NEC is not intended to be a substitute for proper training and experience. Electrical work should only be performed by qualified individuals who have the necessary skills and knowledge. Failure to comply with the NEC can result in serious injury or death. It can also result in property damage and legal liability. It is important to take electrical safety seriously and to follow all applicable codes and regulations. The goal of the NEC is to ensure the safety of people and property from the hazards of electricity. By following the code, you can help to create a safer environment for yourself, your family, and your community. The NEC is a valuable resource for anyone involved in the design, installation, or inspection of electrical systems. It is a living document that is constantly updated to reflect changes in technology and best practices. By staying current with the latest edition of the code, you can help to ensure that electrical installations are safe and compliant. Service entrance conductors, in particular, are a critical part of the electrical system, and it is essential to follow the NEC requirements for their installation and maintenance. Ensuring correct conductor sizing is paramount. The ampacity of the service entrance conductors must be sufficient to carry the calculated load of the building. Overloaded conductors can overheat, leading to insulation damage and potentially causing a fire. The NEC provides detailed guidelines for calculating the service load and determining the appropriate conductor size. Grounding and bonding are crucial for electrical safety. A properly grounded and bonded system provides a low impedance path for fault current to return to the source, which helps to trip over current protection devices quickly in the event of a fault. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding connections to ensure a safe and effective grounding system. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The NEC requires that overcurrent protection devices be properly sized and installed to provide adequate protection. The service disconnect is a device that allows the entire electrical service to be disconnected from the building. The NEC requires that the service disconnect be readily accessible and clearly labeled. Proper labeling of electrical equipment is essential for safety and convenience. The NEC requires that all electrical equipment be clearly labeled with its voltage, amperage, and other important information. Regular inspection and maintenance of electrical equipment are essential for ensuring its safe and reliable operation. The NEC recommends that electrical systems be inspected periodically by a qualified electrical inspector. Electrical safety is everyone's responsibility. By following the NEC and other applicable codes and regulations, you can help to create a safer environment for yourself, your family, and your community.